Hello, welcome to our next video as we're looking at the reactivity of carbonyls. So now we're going to look at reactivity of carbonyls with water, right? There's two ways we can add water or carbonyl. We either can do base catalyzed or acid catalyzed. Now, remember, water is not very reactive, right? So we're going to need something in there to help reactivity, help it increase its reactivity, whether it be an acid or be a base, okay? And we'll do both methods. So we're going to take our carbonyl. And remember, with our carbonyl, this can either be an aldehyde or a ketone. Just drawing this one now, but it can be aldehyde or a ketone. Doesn't matter which one. And we're going to do these reactions in either acid or what? Basic conditions. Okay, acid or basic conditions to get this reaction. Remember, water is not very reactive at all, which is good, right? We don't want it to be very reactive. So we're going to add in either an acid or a base in there to help with our reactivity, make it more reactive. Okay? We'll add these in here, and we're going to generate what? What are we going to add? Addition of our two OH groups. Two OH groups directly attached to the same carbon, okay? We're going to do that reactivity. We're going to generate a hydrate. Okay? We generate this hydrate, known as a hydrate, where we have these two OH groups attached to the same carbon. And we'll go through the mechanism of both reactions, right? So let's start with the base mechanism. So with our base mechanism, you can remember already, we have a base in it, very strong, very reactive. It's not going to wait around, it's just going to react with something, right? It's going to react with something. So let's put our OH in there. And our OH group is going to charge right in. It's going to attack what? Where is it going to attack on this molecule here? What's something that's electron poor on this molecule? Remember, it turns out it's going to be this carbon. We talked about that carbon. Carbon of the carbonyl is electron poor, right? It needs electrons. Attack there. As it does that, what's happening to the bond between the carbon and the oxygen? Where those electrons have to go? The electrons are going to go up. Up, up, up. All right, now we got to this step here where we have oxygen attached to that carbon. We're almost to what we need to get to, right? What are we missing? We're just missing that hydrogen. Now we have a negative charge on the oxygen. What do you think is going to protonate the oxygen, right? What's something we haven't used in our reaction yet that's supposed to be in there? What's something we haven't used? We used the OH. That's right there. What have we not used yet? We haven't used our water, right? And this is where the water comes into play. Oxygen's going to pull off that hydrogen there to generate what? We get that species there where we make our hydrate, right? We make our hydrate, okay? This is our base catalyzed version, our base catalyzed. So this is our base catalyzed mechanism, where first we have addition of our OH group, the carbon, the carbonyl. Electrons go up, negative charge in the oxygen. That's where we then add in our water. Remember, we talked about this already. The water's not very reactive. That's why we have that base. Now let's see what happens when we do our acid catalyzed reaction. We're going to look at our acid mechanism. So very similar to the other one, right? We'll put our carbonyl with our acid in there. What do you think is going to happen first? If you can guess, remember, acid in there, something's going to get protonated. What's going to get protonated? What has lone pairs of electrons that can get protonated, right? It's this one here. Now we have that carbonyl with the oxygen is positively charged because it's got that lone pair of electrons there, or been protonated, right? What's going to happen next? What do we need to do now? Got a negative charge on oxygen. Oxygen doesn't want to be negatively charged or positively charged, right? What's going to happen to that oxygen? Where do those electrons have to go? They're going to go up to the oxygen. The old resonance structure. And so by those electrons moving up to the oxygen, where's that positive charge at now? It's going to be at our carbon. Great. And then what's going to react with that carbon? What's going to react with that carbocation now? Where we haven't used that in our mechanism? We haven't used our water. Now that we generated this carbocation, remember, once we generate the carbocation, it's going to be very, very attractive to our weak nucleophile. Remember, water's not very reactive, but now it has to react because it's a carbocation. It's got to react, right? It has no choice. It's too good to pass up. So it's going to react with that group there. And we're going to generate this species here, right? Now we have what? We have this water attack. Now the oxygen has a positive charge on it. Again, water doesn't want to be positively charged. What's it going to do? What does it have to do? It needs electrons. One way you can get electrons is what? We have to break one of those bonds. We don't, when electrons break the bond, electrons go back to the oxygen. But we can't break this bond because then we'll go backwards. We want to go forwards. So another water is going to come in. It's going to do what? It's going to pull off one of these hydrogens here. When it grabs one of these hydrogens, what happens to the electrons? They go back to the oxygen. And we form our hydrate there, right? And again, you can see for both of these mechanisms, we end up in the same place, right? Our base catalyzed one, which group attacks first? And then we have addition of the water in the second step, okay? Which uses as a hydrogen source to generate our hydrate. We see for our acid catalyzed mechanism, protonation first, generate a positive charge in the oxygen, electrons go back up to the oxygen. Now we generate that carbocation. Again, we have a strong electrophile. That carbon's a very strong electrophile, which then now we can use our weak nucleophile water. We'll have to attack it, right? That's what we see. We always see water attacking strong electrophiles, right? We always see it attacking carbocations, okay? Attacks carbocation. Then we get this form here. Now we have a positive charge on our oxygen. What's going to happen now? Oxygen wants to be neutral. It's got to get electrons. We're going to pull off this hydrogen. The electrons go back to the oxygen to give us our neutral species, our final compound. Okay? So we see with both these mechanisms here, we get to the same place. We have a base catalyzed versus acid catalyzed, right? You can pick your favorite one, which one you like better, right? You can think about which one you like better. I kind of like the acid catalyzed one a little bit better, right? It's a little more fun. But again, both of these steps, we're going to see these steps again in a little bit, right? Particularly, we're going to see this acid catalyzed one again. Now, we've done this with water. What happens now in the next time if we do it, say, with a alcohol? We get something similar, different? I don't know. Stay tuned. Come see the next video. We'll see what we can do.